All right, just thought I would record this quickly in case it's helpful for sort of explaining some of the stuff I was just talking about. Um, so we'll start with layer one in this case, I have Ethereum here. We'll just call it L1. So this is like almost think of it as it's like a computer or something. It's just a data structure or a hard drive. It's a place where data can be stored and logic can be run. It really is like a decentralized computer. And it maintains all of this information or state, as people call it. So Ethereum was like advanced, there were all these smart contracts on it. But because of like how the network operated around 2020 or so, leading up to 2020, it was getting so expensive. Like to do a single transaction could cost $50 or more on this layer one. Um, but there's like all this really strong security behind these layer ones, but people didn't want to spend so much to do transactions, obviously. So then this concept of layer twos came along. Um, called this a layer two. So think of it like this is literally on top of like the layer one or the base chain, as people call it. And what this does, without getting like too complex, it uses all sorts of cryptography and stuff. But it might do something like batch a whole bunch of transactions. So, say one transaction is I'm going to send you $10 of USDC. Um, so I could do that as one single transaction on Ethereum. We'll write that here. We'll say something like send 10 USDC. Uh, but it might cost at that time, especially things are cheaper now, but back then it might have cost me $50 to send those $10. So it's crazy. And I have to pay an ETH in the native token to make that state change. So obviously that didn't make sense at that time. There needed to be a solution. So then like all these different layer twos came along and like not getting too complicated. There's these things called like ZK rollups, optimistic rollups, blah blah blah. But just think of it as simply they're doing all kinds of things so that I could go to this Polygon instead and I could say the same thing like I want to send 10 USDC. But this thing, this layer two, instead of just like doing all of that at once, it might, I'm gonna write that to the Polygon chain, but then it might take, say, there's 100 other people that all want to send 10 USDC or some amount of USD or do a whole bunch of transactions. It's going to, let's find another shape for this. Let's use a circle. So it's got a group of transactions here that it's all going to batch together. And within this group, there might be, let's call it, 100 transactions. It's gonna then, as a single transaction, write that to the layer one chain. So it's taking advantage of all the strong security considerations, the state maintenance of this layer one, um, and it's bundling my transaction with, 99 others. So instead of me paying $50, I'm paying, maybe 5 cents or like something like 1/100th of that amount. And that's kind of how it works. So it's like batching a whole bunch of transactions. They do all other sorts of like fancy processes to essentially make it so it's cheaper to take advantage of all of this unique security and state maintenance of the layer one, but it does it as a layer two. So yeah, that's what a layer two is. It's like a scaling solution to make it cheaper, faster, or those are the main two things. They want to be cheaper and faster than just directly using the layer one. So if we zoom out a little bit more, I drew this. So now like look, we have a whole bunch of these different like layer one blockchains. We've got Solana, Avalanche, Hedera, Sui, Sei, which is a new one. Sui and Sei are two new ones, or like XRP Ledger. Um, and then a lot of these like communicate with each other via these interoperability protocols. And those are things that are like uh, Chainlink CCIP or Axelar. And without, not to get too, this is just conceptual, but they use a way so you can send transactions between these things. So you ultimately end up with like this big, let's just make it a circle. With Chainlink, you end up with this big like underlying internet of smart contracts. And that's what some people refer to as a layer zero. And I've heard of things like as exotic as like layer threes and stuff. I don't even know what the heck those are. But I think if you have this like understanding, this is how the industry thinks of these things, these ideas of like a layer one, a layer two, and then this concept of a zero is like a newer thing. There hasn't really been a strong established standard yet for what this Internet of Smart Contracts is going to be, but it seems like more traditional financial players are leaning toward using something like Chainlink CCIP or Axelar. And then people within like the DeFi space, real like Web3 degen people, they're using these things. Just to kind of like get familiar with some of these names. Those people are really using things called like Wormhole, um, Squid Router, which is powered by Axelar, um, and then Layer Zero is another big one, which is just it's like a brand name, Layer Zero. All of these things they build bridges and ways to like pass message between various blockchains. And sometimes they can even be used for passing messages between a layer two and a layer one, like explicitly. But no, I won't get into all of that. But yeah, feel free to ask any questions or anything. Hope this is helpful.